To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we discussed about the mathematical parts and the mathematical concepts regarding a simple machine. Especially we discussed about the mathematical concepts by taking a lever, my dear children. And we finally discussed that these things even can be applied for the other types of simple machines as well, right? And my dear children, now within this chapter, we'll be discussing about the second main type of simple machine. So the second main type of simple machine is the inclined plane. The inclined plane. So you know that inclined planes can be used to, now let's take a certain heavy mass like an oil barrel. So it's very difficult to lift up this oil barrel to a certain different location. I mean, like to a vertical location, to a vertical height. We won't be able to carry it, right? So in that case, my dear children, you can use the inclined plane to make our work easy. So we have discussed this thing within the introduction of the simple machines, my dear children, right? Within our first chapter, we have discussed that thing. So inclined plane can be used to take a certain object which is at the ground level, right, to a different location which is vertically up. Okay, so to carry a certain object vertically upward, we can use the inclined plane. So by using the inclined plane, we can do the work with ease. Okay, so this is the main advantage of the inclined plane. So here it is given, inclined plane or a ramp can be used to make a job easy. Therefore, inclined plane is also a simple machine. We realized earlier that a force equal to the weight of an object should be applied to lift it up directly. Can you remember in the previous chapter we discussed that in order to lift a certain object, we need to apply a certain force which is similar to the weight of the object. We need to apply a certain force which is similar to the weight of the object. By that way, we can lift a certain object upward, my dear children. So when lifting a certain object upward, we need to apply a force which is similar, to the weight of the object, right? So, but less effort is enough to draw it along an inclined plane. So the advantage of having an inclined plane is that, my dear children, we can apply a lesser force, less effort, that means lesser force, to drag it along an inclined plane. That means, my dear children, we are pushing it along the inclined plane without any trouble, right? Over there, we won't be able to apply a force which is similar to the weight of the object. So therefore, the effort is getting minimized. The effort that should be applied is getting minimized over there. By that way, we can, right, do our work quite easily. Then let us do the activity given to understand how effort that should be applied to draw an object along an inclined plane changes with its inclination. So now we are going to do a certain activity. Within this activity, my dear children, we'll be investigating how does the inclination of the surface or the inclined plane is going to help in dragging a certain object upward. Okay, so to do this activity, we'll be needing these materials. So here we are going to study how the effort applied to draw an object along an inclined plane change when with its inclination. So with the inclination, how the effort is going to change. So we'll be discussing, right, or we'll be investigating about the inclination and the effort needed within this activity. So to do this activity, my dear children, we'll be needing these materials. So what are the materials? First of all, to get an inclined plane, you will be needing a wooden plank. You'll be needing a wooden plank, right? Or else a wooden sheet. If you don't have wooden sheet, my dear children, then you can get a plastic one or else a metal piece, no matter, right? Then we'll be needing a spring balance to measure the weight of a certain object. Spring balance. Then, my dear children, to hold it, we'll be needing another wooden log. Then a brick. Brick means actually here, if you don't have any bricks, then you can find, you can get, some kind of a mass, my dear children. Okay. If you don't have a brick, you can find out some kind of a mass, right? We are going to take that mass, and first of all, we're going to measure it in our normal conditions, and we're going to find out the weight of that mass. Okay. Then, my dear children, by application of a force along the inclined plane, we are going to find out how much of a force is needed to lift that particular weight towards that point. Okay. In simple, that's our idea. So instead of a mass, you can find out any kind of a instead of a brick, you can find out any kind of a simple mass, my dear children. No problem in it. So I'll mention as a mass. Right. Okay. So these are the materials you will be needing. So you'll be needing a wooden plank or else a surface to create the inclined plane. Then a spring balance to measure the weight of the particular mass, which is over here. Then a wooden log to support the the inclined plane. Then, my dear children, a brick or else a mass in order to investigate about the inclined plane, what will happen to the force needed or the effort, right? So here you can use a brick or else any kind of a mass, right? So these are the materials that you need, my dear children. So now let's head on to see the method of doing the activity. Let's see. Now in the method, my dear children, here it is given, construct an inclined plane using several bricks and the piece of plank. Fix a loop to one side of the block of wood. Couple the block to the hook of the Newton balance. Find the force necessary to move the block of wood along the plane. So, my dear children, here you can do this thing or this practical in both ways, right? No problem in it. So, if you don't have, if you have several bricks, then you can create a inclined plane by using the bricks, or else, my dear children, you can get another wooden log. Then you can place it over like this, right? You can place it like this. Then, my dear children, you can place the other wooden sheet like this, the inclined plane. So you can get that brick and you can get that thing as the mass. Okay. Or else, my dear children, according to the points given here, you can take the bricks and you can keep it like this as the support for the inclined plane, and you can get that wooden log as the mass and you can hang it on the spring balance. Then you can find out you can calculate the effort needed to lift it and to drag along the inclined plane. No problem in it. Okay. Now here specifically they have mentioned, right? You have to construct the inclined plane using the bricks and the piece of plank. But however, you can utilize the wooden log and the wooden plank and you can use that brick or the other mass as the object that we are going to take or that we are going to lift. Okay, no problem in it. So here, let's see. Reduce the inclination of the plane by removing one brick and repeat the above steps. Take several readings by reducing the inclination of the plane by removing another brick. Now, my dear children, instead of a brick, now when I'm doing this activity in our laboratory now, so instead of bricks, my dear children, I can use a stand. Okay, so by using the stand, my dear children, I can move up and down the inclined plane quite easily. So when I'm doing this activity, I'll be using a stand, a simple stand. So by utilizing a stand, my dear children, I can quite easily move up and down. I mean, like, I can reduce or increase the inclination without any trouble other than using bricks. Okay, so in here they are mentioning that reduce the inclination of the plane by removing one brick and repeat the above steps. Take several readings by reducing the inclination of the plane by removing another brick. That means from brick by brick you have to remove and you have to reduce the inclination. Now over there, when I'm doing the activity, I'm going to use a stand. Then by that way, when moving up and down that particular lever part, I can move it up and down. Then from that, I can reduce or increase the inclination. Okay, right. Compare how the effort changes with the inclination of the plane. Then what you have to do, you have to compare what will happen to the effort with the inclination of the, right, with the inclination of the, the plane, right? What will happen when increasing the inclination of the plane and what will happen when decreasing it. So you have to investigate it. So this is our activity. I hope that you got the activity, my dear children. Okay, right. So let's head on to the laboratory. Then we'll conduct this activity. Then we'll come back to the classroom once more to write down our observations and our conclusions, my dear children. Okay, so when I'm doing this activity, right, I'm not going to take readings to over here, right, because by using the readings, my dear children, right, it's not necessary to take the readings to here when we are writing down our observations and conclusions. But remember to note down the, I mean, like, to compare the two reading sets, right, to compare the reading sets that you are going to take. So always try to compare those readings. Okay, right. Then, so I hope that you got the idea. So let's head on to the laboratory and we'll do the experiments. Then once again we'll come back to the classroom to write down our observation and conclusion. So my dear children, as you can see, this is the setup which we can use to demonstrate the inclined plane. So this surface is behaving as an inclined plane. You know that this is the horizontal ground level, so it is showing an angle. That means this surface has an inclination to the inclination to the horizontal ground, which is over here. So this surface is behaving as an inclined plane right now. So what I'm going to do is, at 3 different intervals, I'm going to find out the force needed to carry this weight upwards. In order to do that, I have with me, you know that this instrument is the, right, this is the Newton balance or else the spring balance. So this is a hook over here. Now let's see how much is the minimum force needed to lift this weight upward. Okay, now you can see that it's gradually moving up. Observe the force needed to lift it up. See, now at this moment the weight is moving slightly upward. Get the reading, a nearest reading. So exactly under the 4 Newton of force, right, it's moving upward, my dear children. 4 Newton of a force. See, when the Newton balance shows the value of 4 Newton, it's moving upward gradually, right? So 4 Newton, you can observe the inclination very well, right? Now we are going to change the position. We'll change the position and once again we'll observe what will happen. Right, my dear children. Now the second instance. Now you can see that the inclination is somewhat lesser than the previous case. Once again, so I am going to apply certain amount of force by using the spring balance, and I am going to measure out the minimum force needed to lift the weight upward. Let's see. Right, now you can see that the weight is moving upward. Now the force which I have applied is nearly around 3.5 Newton, my dear children, nearly around 3.5. So you can see that the inclination is somewhat less right now. In the previous case, I had to apply 4 Newton of a force. But during the reduction of the inclination, the force needed to apply to take this wooden block upward is equal to 3.5 Newton. Now once again we'll observe, by reducing the inclination even more, what will happen to the force that we need to apply in order to carry the wooden block upward. So my dear children, this is the third and the final step right now. So the inclination is even less. This is the one which has the least inclination out of the three instances. Once again I am going to apply a certain force and I am going to check how much is the force needed. So you can see that the object is moving upward. The reading is nearly 3 Newton, my dear children. It's nearly 3 Newton. Once again, let's see. See, now it's moving upward and the reading is nearly 3 Newton. So we can see that the reading has even reduced in the third instance up to 3 Newton. So 4, 3.5 and 3. So when reduction of the inclination, we can clearly observe the force that we need to apply is also going to reduce, and with ease we can carry the weight upward without any trouble. Okay, right. So let's head on to the classroom and we'll observe the other contents in the lesson then. Right, my dear children. So we did the activity. So you could clearly observe that when the inclination is low, right? When the inclination is low, quite easily we can carry the object upward. When the inclination is high, it's difficult to carry the object upward. Okay. So this was our, right? This was our observation. And from that we can conclude that when the inclination is less, the effort is also less. When the inclination is high, more effort should be utilized. Okay, so we can write down our observation then. When the inclination is high, it's difficult to carry, it's difficult to move the object upward inclined plane. When the inclination is less, when the inclination is less, it's easy to move the object upward along the plane. So the conclusion, when the inclination is less, effort is needed, and when it is high, effort is also high. So when the inclination is less effort is needed, and when it is high, effort is also high. So observation, when the inclination is high, it's difficult to move the object upward along the inclined plane. When the inclination is less, it's easy to move the object upward along the plane, okay, the inclined plane. So this is our observation, my dear children, and the particular conclusion. Right, my dear children, so this is our observation and the conclusion then. So always remember, when the inclination is less or high, it is going to directly affect the effort that we are going to apply to move that particular object, okay, right then. So you may have realized that the effort decreases with the decrease of the inclination of the inclined plane and vice versa. So like I said, my dear children, from this particular activity, we can come into a conclusion that while decreasing the inclination, we can decrease the effort given. When increasing the inclination, the effort also getting increased, okay, right. So when mechanical advantage increases with the decrease of effort. So when the effort is getting decreased, the mechanical advantage is also going to increase, okay. When the effort is going to decrease, the mechanical advantage is also going to increase, my dear children, okay. So lesser the effort, higher the mechanical advantage, okay. Lesser the effort, higher the mechanical advantage, right then. So this is about the inclined plane then, okay. Now let's head on to see the next. So examples for inclined planes used in day-to-day life. The examples for the inclined planes. So my dear children, number one given, wedge. So wedge is like, some kind of a wooden or else a metal plank kind of an object like this. It is having some sort of an inclined surface. So the wedge can be inserted into a certain crack like this. So this can be inserted into a crack. Then by hitting on the wedge, my dear children, we can tear off the wooden log. So during the ancient times, even in nowadays, right, in order to break down large wooden logs, in order to, separate large wooden logs into several pieces, we use the instrument, or we use this simple machine called the wedge, okay, the wedge. Next one, the staircase. You know that, this staircase, right? Even in your houses, you might have staircases. So staircase is being used at our houses and in our buildings to move from one story to another in our house, or else in a building from one story to another. Okay, so here we are moving vertically upward, but however we won't be able to move vertically upward directly. I mean, like perpendicular to the ground, we won't be able to move up. It's difficult. So in order to overcome that process, a staircase has been built. So the staircase is showing some kind of an inclination to the parallel ground. So by that way, quite easily we can climb up, right, without any trouble. So this is the second example, day-to-day example for inclined plane, the staircase. Number 3 given, the screw jack. Okay, the screw jack. The screw jack is also the same, my dear children, right? There's a screw and there's a jack. So the screw is rotating and the jack is being lifted off. Screw jack, right? Then the screw nail. Now you might think that the screw nail, it's not an inclined plane, no. There is a screw. However, it's not an inclined plane. No. You won't be able to observe an inclined plane in the screw nail. Of course, you can, my dear children. I'm going to explain it to you when I'm going to laboratory by explaining these things. Okay, right? So first of all, we'll get to know what are the examples. Then at the laboratory, I will show that to you that the screw nail is also a type of an inclined plane. So screw nail, remember, it is a inclined plane. Okay. Then the next one, the ladder. So we use the ladder to climb up from certain position to a different position, like vertically upward. Especially to climb onto a certain roof, we use the ladder, right? From ground level, we are climbing onto a certain roof. In that case, we are using this instrument called the ladder. So we are not going to keep the ladder like vertical up. It's very difficult to climb up in that kind of a situation. However, we are keeping the ladder at an inclined plane. So by that way, we can climb up. Okay. So this is how the ladder is going to work, my dear children. The ladder, right? So by climbing up from the ladder, right, we can climb up to a certain height without any trouble. I mean, like with ease, we can climb up. Okay. Here the inclination of the ladder is helping us, right? It is the one which is helping us to carry our weight to that particular location. Okay. Right then. So this is the third final example for the inclined planes in our day-to-day life, the ladder. So the wedge, staircase, screw jack, screw nail and ladder are examples for the machines, simple machines, right, that reflects the inclined plane in our day-to-day life. Right, my dear children? So I hope that you got the idea about these examples. So to clarify these things even more, let us head on to the laboratory. So I promised you that I'm going to show that the screw nail is an inclined plane. So let's head on to the laboratory and we'll investigate about further things related to these inclined planes. Okay, and once again we'll come back to the classroom to study about the further things related to the lesson part. So my dear children, here we are going to investigate the users of these simple machines. So we have identified several simple machines, my dear children. So I have with me a wedge. You know that wedges are used to split off a certain object. Especially we use a wedge to split off a wooden block, right? Not like these ones, but heavy wooden blocks can be removed or can be splitted off by using a wedge. So here what we are going to do is we're going to apply the wedge onto a surface like this. Then by applying a certain force on the wedge, we can separate. As you can see here now, when I have inserted the wedge into the wooden block over here. See, now it has been separated. Now if I'm going to apply a greater force to here, and if I'm going to hit it, right, and if I'm going to hit it, for sure this is going to separate into two parts. Okay, so this is the wedge. You know that wedge is having an inclined plane, see, and with ease it will get inserted into a block or else into a wooden block without any trouble. So this, by using a wedge, we can do our works very easily in our day-to-day life. So after that I have the screwdriver. So you know that we use these screwdrivers in order to remove or tighten a screw nail. So screw nail is like this, my dear children. See, this is the screw nail. So we have identified the properties of a screw nail. So you know that we can insert the particular type of a screwdriver onto this, and we can, you know, tight it down, or else if you want, you can loose it up like this, or else tight it down. So you know that if you have a hammer and a normal iron nail, we have to hit it and it's very difficult. But however, if you have a screw nail, we can do the same work with ease, and the strength given out by the screw nail is even more greater than the normal iron nail, my dear children. So screw nail is a good example for the wheel and axle. And also, my dear children, here we can observe some amount of a, or some kind of a inclined plane. As you can see, the pattern of the screw nail is like in a spiral manner. So this is like an inclined plane. How can you say it? So to demonstrate that thing, I have a paper with me. So you know that this is an inclined plane. If I'm going to place it like this, so you can see it very clearly that it is an inclined plane. See, what I'm going to do is I'm going to wrap this thing like this on this piece of paper, on this pen, my dear children. On this pen I'm going to wrap this thing. So as you can see here, so now I have used that inclined plane, and my dear children, I wrapped it around a pen, as you can see here. So this is the pen that I have with me, which wrapped around with an inclined plane. So you can see the marking. So this marking is very identical to the one, the screw nail which is over here. See, so this is also a good example for the inclined plane. Now when I'm going to remove it like this, see, this is an inclined plane. Right then. So for several day-to-day activities, we use several kinds of or different kinds of simple machines, my dear children. So these are like few examples. There are like heavy examples for simple machines. By using or by collection of these simple machines, even we can make somewhat complex machines like the bicycle. So within a bicycle, we can observe several simple machines, my dear children, right? So we use these simple machines to do our day-to-day usual activities, to ease our day-to-day activities, my dear children. So let's head on to the classroom once more and we'll observe the other contents in the lesson. Right, my dear children. So like I said, can you, I think you can observe that, right? You have observed that quite well, that the screw nail, the screw, right, which is around the nail, right? The screw kind of nature which is around the nail, that's behaving as a inclined plane. So I have shown you how the inclined plane is going to work. Okay. So my dear children, the inclined plane. These are the examples for the inclined plane. So inclined planes are helping us, right, to move a certain object vertically upward to a different location. So now let's head on to see calculations regarding these inclined planes, my dear children. Okay. So you are given with a question here. Weight of a barrel of oil is 600 Newton. Using an inclined plane of 4 meters long, it is lifted to the deck of a lorry which is 1 meter high from the ground. The force exerted to push the barrel along the plane is 200 Newton. So this is the ground level. Then this is the inclined plane. Then this is the deck, okay, of the lorry. So let's imagine like that. Okay, so this is the deck. So here to here height is given as 1 meters, my dear children. Okay, 1 meters. Then the length of the inclined plane is given as 4 meters. 4 meters. So weight of the oil barrel is 600 Newton. So let's imagine that this is the oil barrel. So I'll take it like this. Okay. Right. So this is 600 Newton. Weight. It is always acting downward, right? 600. Then force of 200 Newton, which is the effort, is applied on this thing. So a person is rolling this object along 4 meter distance. To take it up to a height of 1 meter from the ground level, weight of the barrel is equal to 600. These are the things which is given in the question. Now let's see what are the questions that have been asked. First of all, mechanical advantage of an inclined plane. Mechanical advantage. So already you know that mechanical advantage is equal to my dear children, the load division the effort. So load is equal to 600 Newton. Effort is equal to 200 Newton, right? 200 Newton. See, here it is given as 600 Newton, which is the weight of the oil barrel, 600 Newton. Then effort, right, that effort which is given, or the push which is given to take the barrel along this inclined plane towards up, is equal to 200 Newton. So my dear children, 600 division 200 should be our mechanical advantage. First of all, the 2 Newton values are getting cancelled. 2 zeros to 2 zeros are getting cancelled. Then 6 over 2 is equal to 3. I told you that this is just equal to 3. Just equal to 3. There are no any other units in here, as it is a ratio. Okay. So the mechanical advantage is 3. Mechanical advantage is 3. Which means you'll be utilizing only 1/3 of the load as the effort in operating this simple machine. However, I told you that it is somewhat lesser than that, right? The efficiency is somewhat lesser. It's going to be somewhat lesser than this, right? Can you remember? Because of the frictional force. However, theoretically, it's equal to 1/3 times the load. Okay, theoretically. So this is the mechanical advantage then. Right, then the next one. Let's see what is the next one then. Velocity ratio of an inclined plane. Velocity ratio. So velocity ratio is very simple, my dear children. Now let me take you to the previous one which I have drawn the figure. Velocity ratio means distance traveled by the effort division the distance traveled by the load. Distance traveled by the effort. So the effort has traveled 200 Newton of a force has traveled along the inclined plane towards up like 4 meters. That's the distance traveled by the effort. Distance traveled by the load is equal to just 1 meter. Just 1 meter. So my dear children, distance traveled by the effort division the distance traveled by the load is equal to 4 meters over 1 meters, which is equal to 4. So let's do the calculation then in here. Velocity ratio number 2. The previous one was number 1. I'll mark it as number 1 in here. The same question, okay? So velocity ratio. Velocity ratio is equal to displacement traveled by the effort right? Displacement traveled by effort division displacement traveled by load. So displacement traveled by the effort, it is equal to displacement traveled by the effort along the inclined plane. The effort is traveling like around 4 meters. Then the displacement traveled by the load is just 1 meter. So meters to meters is getting cancelled. When you divide 4 by 1, the answer is 4. Answer is 4. So this is the second one, which is the velocity ratio. So the velocity ratio is equal to 4, my dear children. Velocity ratio is equal to 4. Now the third, the efficiency of the inclined plane. Efficiency. So efficiency is equal to mechanical advantage over velocity ratio, right? Velocity ratio, and multiply this one by 100. So mechanical advantage, we found out that thing in our first question. See, mechanical advantage, load over effort, it is equal to 3. Then the velocity ratio, displacement traveled by the effort, displacement traveled by load. So when you divide those two, value is equal to 4. So 3 over 4 into 100. So my dear children, you can get the answer as 75%. 4 times 1, here 25. So 25 times 3, it is equal to 75%. 75%. Or else you can find out by using the work done. Okay, work done by the you find out the work done by the effort, then work done by the load, then you get the fraction and multiply it by 100% to get the answer. Okay, but other than that, the efficiency, this thing is quite easy. You divide the mechanical advantage by the velocity ratio and multiply it by 100 to find out the efficiency. Okay, so the efficiency of this one is now equal to 75%. Then the next one, work input and the work output. So work input is equal to effort multiplication displacement of the effort. Right? Effort multiplication displacement of effort. So effort is 200 Newton. It has traveled like 4 meters, right? So equal to 800 Newton meters, which is further getting equal to 800 joules. Then work output is equal to load multiplication displacement of the load. So load is just 600 Newton. You multiply by the displacement of the load, which is equal to just 1 meter. So here 600 Newton meters or else 600 joules can be obtained, right? So the work input and the work output, right? Work input is 800 joules or 800 Newton meters. Work output is equal to 600 Newton meters or else 600 joules. So now you can see the relationship, right? When you divide 600 by 800, see, you divide 600 by 800 and when you multiply it by 100, once again you can get the same answer as in the previous case, which is equal to 75%, my dear children. This is the one which I have told you. Can you remember? Efficiency is always equal to what? Work output division work input multiplication 100. Right, my dear children? So as you can see, the same thing can be observed when you take the ratio between the work output and the work input, and when you multiply it by 100, right? The same thing can be observed. So that's why I told you that you can find out the efficiency by using the mechanical advantage and also by using the velocity ratio, and when you divide those two and multiply by 100, you can get the answer for the efficiency. Or else, my dear children, like I did in here, you can get the work input, you can get the work output, divide the work output, okay, divide the work output by the work input, and then, my dear children, you can multiply that value by 100 to find out the, right, to find out what? To find out the efficiency. Okay, so here I have found out by using that one also. So I hope that you got the idea of finding the efficiency of the inclined plane. Okay, so I'm going to erase the second to keep you clean with the calculations which I have done over here. Okay, right there. Then efficiency of an inclined plane, once again we'll do it in the other way around. So efficiency is equal to work output work input multiplication 100%. So earlier, let me take to the earlier slide once again. Work input 800, work output 600. So work output 600, work input 800. Multiplication 100. Joules to joules is getting cancelled. 2 zeros to 2 zeros is getting cancelled. Here 3, here 4, 4 times 1, here 25. Once again, you can get the answer as what? 75%. The same answer is coming for here also, right? The efficiency. So efficiency can be calculated according to these two ways, my dear children. Okay, right then. Then, my dear children, we have discussed about the inclined plane, no? And even we did some calculations related to the inclined plane as well, right? We investigated about the inclined plane, right? About the screw nail, right? In our laboratory, and have even done several calculations to the inclined plane finally. Now it is time to study about the third main type of simple machine, which is the wheel and the axle, right? Wheel and the axle. So here it is given. Wheel and the axle is a simple machine which can be used to make a job easy. As wheel and axle are connected to the force applied on the wheel can be transferred to the axle to do the job. So here there is a wheel and an axle, right? So we are rotating the wheel, and it is the force which is given to the wheel is transferred to the axle. So the axle is working now to do the work or the job, right? So by that way we can make our work quite easy, right, my dear children? So here the specialty is that the radius of the axle is somewhat smaller than the radius of the handle. I mean, the handle has a higher radius than the axle, my dear children. Otherwise you won't be able to do the work easily, right? So windlass is a such machine with wheel and axle. So this is windlass, right? Windlass. So you're going to wind it like this by using the handle. So when winding it, you know that here there is a rope, then rope is, you know, wrapping around the wind over here. So by that way we can lift off a certain, you know, mass through the windlass quite easily, right? So windlass is a such machine with wheel and axle. This windlass is made by fixing L-shaped handle to a long cylindrical stem which is rested on the stands, so that is can be freely turned. So like I said, there is a handle, L-shaped handle. There is a, you know, large spherical or a cylindrical large cylindrical kind of a stem, right? So which is being fixed to the handle. So when I'm going to wind it, right, this cylindrical object or the stem is going to rotate and the rope connected to the windlass is getting winded on the spherical or the cylindrical stem. By that way, my dear children, the load is coming up. If you want to loosen it down once more, you can turn it round the other way like this. In that case, the rope will gradually loosen and it will come down. So this is the windlass, right? So we use these things especially in mining, gem mining, right? Sometimes, my dear children, when digging some wells, we use this windlass, right? So this is the windlass. So you turn that handle here and there, right, to either ways in order to lift the bucket up or turn it down once more. So this is the windlass. Then the rope is wound around the stem and bucket is tied to the other end of the rope. When the handle of the windlass is turned, the bucket goes down into the mine. So like I said, so when you are turning it down, it goes downward. The windlass, the one which is connected to windlass, right? The bucket, it goes downward. When the handle is turned the other way, bucket comes up with load filled into it. When the handle is turned one round, the rope is also winds one round the stem. So here, let me take you to the previous one. When one rotation is being completed, the rope is going to complete one round. It's going to complete one wind around the cylindrical stem. Okay. So by that way, when turning it for several rounds, what will happen? The rope will gradually, right, wind it around the stem of the stem of the cylindrical object. Then by that way, the load is coming up, or the load is coming, actually the load is coming up. So when I'm going to turn it in the other way around, one by one these winds are getting loosened, then the load will come down. Not the load, actually it's the empty bucket. So when the handle is turned once, the distance traveled by the effort is equal to the circumference of the circle of the handle turned. Exactly, no? When the handle is turned once, when I'm going to turn the handle just once, that means just one cycle, then the distance traveled by the effort, is equal to the circumference of the circle of the handle which turned. It's equal. So when I'm going to turn the handle just once, then my dear children, this particular thing is going to rotate, no? So that means upon the rotation, some kind of a circumference is being covered. That circumference is exactly equal to the distance traveled by the effort. Okay. Then sometimes load is lifted by a distance which is equal to the circumference of the stem. Right? Actually, it's not sometimes, it should be same time, right? In your textbook, there is a small bit of a error, my dear children. It should be same time. Okay. So, same time, load is lifted by distance which is equal to the circumference of the stem. So, here same time. So, same time, right? Same time, load is lifted by a distance which is equal to the circumference of the stem, right? So, now load is winded to the stem over here. So, when it is rotating like this, it's equal to the circumference the load is traveling, so which is equal to the circumference of the handle. Then here, right, when the bucket is coming upward, the rope of the bucket is winding around the stem, no, so in here the cylindrical stem is having a certain circumference, so that circumference is equal to the load, right? That circumference is equal to the distance traveled by the load, right? Distance or the displacement traveled by the load. So the basic idea in the wheel and axle is that the work done by the load and the axle, right, can be by the load and the effort can be calculated quite easily by multiplying the effort with the circumference of the handle. And to find out the work done on the load, you just need to multiply the load with the circumference of the stem. Stem means the axle. Okay, right then. So, same time the load is lifted by a distance which is equal to the circumference of the stem, right? So, here let's take, see, this is now the effort arm, this is the effort, right, arm, effort arm, and this is the load arm. I mean, like, this is the distance traveled by the, right, distance traveled by the effort, this circumference. This is the circumference which is equal to the, or the distance which is equal to traveled by the distance traveled by the load, the circumference which is getting equal to the distance traveled by the load. Okay, so here it is given length of the handle equals to the radius of the circle. So length of the handle is equal to the radius of the circle, which is given as R1. The diameter of the circle is 2 times R1. Then the circumference is 2 times R1 into pi, right? 2 pi R, no. So 2 times pi, 2 times R1 into pi is the circumference of the, right? It is the circumference of the handle, right? This is the circumference of the handle. As you can see here, it is marked R1. So the entire circumference is equal to 2 pi R1. Okay. Therefore, the distance that the effort travels for one turn of the handle is equal to 2 pi R1. Then the next point, then in the same way you can see that here it is marked as R2. So the distance traveled by the load in the same time should be equal to 2 pi R2, right? So let's see. Therefore, the distance that effort travels for one turn of the handle is equal to 2 pi R1. If the radius of the cylindrical stem is R2, then its diameter is 2R2. It's very simple. If the radius is 2R2, then the diameter is 2 times the R2. Then the distance that load is lifted for one turn of the handle is equal to 2 pi R2, right? So I hope that you got the idea, my dear children, right? Here we have found out the distance traveled by the load and the distance traveled by the effort separately. Then, my dear children, therefore velocity ratio of the wheel and axle. The velocity ratio, let's see. Velocity ratio means, my dear children, it is the right, velocity ratio is the distance or the displacement of effort division displacement of load. This is the velocity ratio. So displacement of effort division displacement of load. Let me take you to the previous one then. The length of the handle equals to radius of the circle R1. The diameter of the circle then 2 times R1. Then the circumference is 2 times R1 into 5, which is equal to 2 pi R1. So the distance that the effort is going to travel is equal to 2 pi R1. So here effort has traveled 2 pi R1. Okay, then the division. Once again, therefore, if the radius of the cylindrical stem is R2, this is the cylindrical stem, right? This one, cylindrical stem. Then it's if the radius is R2, so here in the cylindrical stem the radius is R2, then the diameter is 2 times R2. Then the distance that the load is going to lift for one turn is equal to 2 pi R2, right? So the circumference is equal to 2 pi R2. So let's write down that one then. Two to two is getting cancelled, pi to pi is getting cancelled. So velocity ratio is equal to R1 over R2. What do you mean by that, my dear children? What did we took as R1? What is the item that we took as R1? Right? Let me explain. So velocity ratio is equal to R1 over R2. So R1 is equal to, right? R1 is equal to, it is the radius of the wheel, my dear children. And R2, that's the radius of the axle. See, this is the wheel, this is the axle. So radius of the wheel is R1. Radius of the wheel is R1. Then radius, right, previous one, then this is the axle. Then radius of the axle is R2. Radius of the wheel is R1. Radius of the axle is R2. So R1 over R2 means, my dear children, velocity ratio of wheel and axle can be calculated by dividing radius of the wheel by the radius of the axle. So when you divide the radius of the wheel by the radius of the axle, we can find out the velocity ratio, right? The velocity ratio of a particular, right? Of a particular what? Wheel and axle. So this is the velocity ratio of a wheel and axle, my dear children. Okay. So now you are given with certain examples for the wheel and axle in our day-to-day life. So this rotating handle can be rotated, right, in order to turn a certain thing up and down, or else in sometimes when we are utilizing this instrument, right, in our day-to-day life, right. Then in here also, when removing nails, this particular instrument is being used, right. So here also you are inserting that into the nut, then you are rotating it. By that way we can remove the nuts. Then this is way more, the third one given in here, you know, the screwdriver, right. This is way more familiar to us. So the screwdriver is also a better example for wheel and axle, my dear children. Here, this is the handle. It is having a certain it is having a larger, like a larger diameter or else a larger radius. So it is acting as the handle, right? Then this is the blade, my dear children. It behaving as the axle, right? So when giving out a certain force on the handle and when rotating it, the blade is going to do the work for us. That means unscrewing the screw nails, right? So this is the screwdriver, my dear children. So we use the screwdriver in order to remove screw nails from a certain surface. Okay, so these are the examples for the wheel and axle. So I hope that you got the idea about wheel and axle as well. Right then, so let's head on to the laboratory, my dear children. We'll investigate about these wheel and axle, the examples related to wheel and axle, and once again we'll come back to the classroom to write down to investigate about further things related to the lesson part. Okay, so let's head on to the laboratory and we'll identify the examples related to the wheel and axle, and once again we'll come back to the classroom then. So my dear children, here we are going to demonstrate the action of wheel and axle. So this is the axle, my dear children, which is been fixed to a certain clip so that I can rotate it very well. Okay, with ease I can rotate it like this. So as you can see here, this is a weight or else a load wrapped around this axle which is going to rotate when I am going to turn it. So this is the one which is going to behave as the axle over here. And when I'm going to rotate it like this, you can see without any trouble, this weight is going to lift upward. See, this is going to lift upward without any trouble. That means with ease we can rotate this handle which is over here, and by the rotation of the handle I can lift the weight. See, so when I'm going to lose it down, once again it goes down. See. So this is very simple, my dear children. So this is a very simple demonstration how to use the wheel and axle, right? So the wheel and axle is also being used to lift certain weights to a certain direction. I mean, like to upward, right? If you go to a construction site, you know that for the upper floors, the loads or the certain raw materials should be transported. In that case, my dear children, we use the help of wheel and axle sometimes. Then there are even more examples for the wheel and axle. The next one would be the steering wheel. You know that when you take the steering wheel of a vehicle, it has a certain axle which is going through the tube which is in the vehicle, and that tube is connected with the steering wheel. Okay, so the steering wheel has a certain large amount of, like the diameter or the radius of the steering wheel is somewhat higher than this one, or the axle which is going to rotate. So when I'm going to rotate the steering wheel, the axle connected to it is going to rotate, and because of that the wheels are going to turn, wheels of the vehicle are going to turn. So over there also the axle and the wheel can be observed. Then when you take screwdrivers, this particular part is going to behave as the axle, and this is the wheel. As you can see, the wheel has somewhat greater diameter than the axle, so that we can rotate it without any trouble. Okay, and also this is another type of a screwdriver, right? And also, my dear children, when you observe a key, you know that we use these keys in order to open or close our doors. So key, this part is somewhat smaller, however the head of the key is somewhat larger than the part that we are going to insert to the keyhole, right? As you can see here, this is the part that we need to insert it to the keyhole like this, and this is the, right, this part is the head of the key that we are going to hold it. Okay, so by holding the head like this, we insert it to the keyhole and we are going to rotate it. So this particular part which we are going to insert into the keyhole behaves as the axle, and this area and this area where we are going to touch it, this is the part which is going to behave as the wheel. So wheel and axle can be also observed when you are turning keys. Okay, so these are the examples for wheel and axle, my dear children. Okay, so wheel and axle is often used in day-to-day life to do our works easily, right? So let's head on to the classroom and we'll observe the other contents in the lesson. Right, my dear children, so we have investigated about the wheel and axle then. So those are the examples for the wheel and axle. So I hope that you got the idea about the examples related to the wheel and axle then, right? So my dear children, with that one, I'm going to finish up this chapter. So within this chapter, we discussed about the inclined plane and we discussed about the wheel and axle, and also we discussed several questions regarding the inclined planes as well, right? And to find out their mechanical advantage, to find out the velocity ratio, to find out the efficiency, and also the work input and the work output as well, right? So we did these things within this chapter, my dear children. In our next chapter, we'll be doing the last and the final simple machine, which is the pulleys. Okay, so we'll be investigating about the pulleys, and we'll be doing questions related to the pulleys as well, and finally we'll be investigating about the systems of pulleys. Then, my dear children, we'll be focusing about the questions in your textbook. Then after that, we'll be going on to the questions, extra questions from the simple machines lesson part. Okay, so stay with me till the end of the lesson to get the knowledge about this lesson part then. Okay, so it's very important to do questions from each and every lesson, my dear children. So I'll be providing some extra questions for you guys as well. So the questions are the very important ones. So stay with me till the end of the lesson, right? We'll do some extra questions regarding this lesson part. Okay, so with that one, I'm going to finish up this chapter, my dear children. So I'll meet you with the next chapter to discuss about the pulleys then.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.